Well, thank you very much for that very kind introduction. It's really a pleasure and an honor to be here. I want to talk a little bit today, mostly about how statistics is used at Google, and not so much because it's special there, but because I think that this is the kind of thing that every company in Silicon Valley is doing these days, and I think by extension every company in the world will be focusing on in the next several years. So I wanted to give you a little taste of who I am, what I do, and the way we use statistics at Google. So let's start with me. As you heard, I got my undergraduate degree at MIT, and then my master's in math at Berkeley and PhD at Berkeley in economics. But while I was there, I wasn't quite sure that I wanted to do mathematics or statistics, so I took courses from Peter Bickel and from Lehman and a few others in the stat department. I ended up going down the math route. I'm not sure I made exactly the right choice there, because I found in my current job, at least, that statistics has ended up being very, very important. And I worked for Dan McFadden, who's an economist who got the Nobel Prize for his work on using logistic regression as a way to model consumer choice theory. And when I went back to MIT as an assistant professor, they asked me to teach the undergraduate stat course that was required for the economics majors at that time. And I have to say, I've often felt that's when I really learned statistics, because you can go to all of these courses and absorb the mechanics, but when you have to explain it to somebody who's never thought this way before, you get a much deeper understanding, in my view. Now, most of my work has been in economic theory and modeling, and when I went to University of Michigan in the 70s, around 1992, I started doing some work on the internet. Now, at that time, the internet was actually run at the University of Michigan. When I say the internet, I mean the internet backbone that connected together the major US research universities. And I got fascinated by this, maybe obsessed would be the word, and started working on economic issues relating to the internet. Back in 1995, I ended up getting a letter from UC Berkeley that said, "We're starting a new school of information, and your name has been put forth as dean. Would you be interested in taking on this role?" So in 1995, I moved to Berkeley, started a school whose focus was information management, and did that for about 7 years. So along the way, I wrote a book with my colleague, former student Carl Shapiro, called Information Rules, which was about the economics of the information age, I guess. And then from 2000 to 2007, I wrote a monthly column for the New York Times, which was related to similar topics. Now at Berkeley, if you're a dean and you can stay out of trouble for 7 years, you get time off for good behavior. I found out it's not as easy to stay out of trouble as you might think, but at least they were charitable and gave me the year off. So I had known Eric Schmidt. He was a Berkeley alum, and he invited me to come to Google. He said, "I've joined this cute little company. There are only about 350 people, but we're having great fun. Why don't you come down and spend some time here and see what we're doing?" So I did that in 2002. I had such a great time. I stuck around. Even when I went back to Berkeley, I continued to consult at Google, and then I shifted over full-time in 2007. And 2009 is the famous New York Times quote. I'll give you a little background in that. Because I wrote for the New York Times, I knew several of the reporters there, the technology people, and I remember Steve Lohr came by once and said, "What's new, what's interesting, what's exciting?" And that's when I launched into the discussion about statistics, because I had become aware that more and more data was being collected by Google and other organizations. And the real scarcity, the difficult thing, was how do you get that data to tell a story? You know, there's a line in econometrics, if you torture the data long enough, it will confess to anything. And it seemed to me that we better start honing our tools on torturing data, mining data, examining data, however you want to put it. Now, when I first came to Google, I asked Eric, what do you want me to work on? And he said, this was in 2002, so he said, why don't you take a look at this ad auction? I think it might make us a little money. And the ironic thing, of course, is as late as 2002, Google started in 1998, didn't really get going for a year or so, but there were a couple hundred people there. Even as late as May of 2002, Google wasn't completely sure of what its business model would be. So I will talk a little bit about how that works because it is quite an interesting exercise in economic modeling and statistical modeling. And while I was doing that, one day somebody came by and said, can you help me forecast our query growth? And I said, well, what do you do now? She said, well, I take this table of numbers in Excel and I highlight the column and I click on the button that says forecast. So I said, well, we might be able to improve a little on that method. It took me, I remember I spent several hours trying to figure out that what Excel meant by exponential growth. Turned out they meant geometric growth, but there were a lot of episodes like that of struggling with Excel. Then after that, I started working on some questions involving advertiser churn, sort of survival analysis from a statistical point of view, estimating lifetime value, how much it was worth acquiring new advertisers, what contribution they'd bring to the company, et cetera, et cetera. So I'm going to talk about a few of these things in a minute or two. Now, we put together a group that was me as the nominal statistician. As I said, I don't really consider myself a professional statistician, but I knew more than some of the other people, so that qualified me. And we got some computer engineers, some data people, and we had a group called AdStats. And what AdStats did is it examined the characteristic, the behavior of the ad system, which is where all the revenue came from. And pretty soon, other people started coming over to AdStats and saying, gee, would you take a look at this problem for me? Or how do we go about solving this? Or how would you deal with this set of data? And so as the company grew, the line outside of our doors got longer and longer, and finally people started saying, heck with it, I'm going to hire my own analyst. I don't need to go with these AdStats guys. And so we started hiring analysts. So an analyst would be, at Google, a statistician, maybe a mathematician, operations research, finance, some area that involved quantitative analysis. And pretty much every product team at Google has one or more analysts, and their role is to work with the engineers and work with the management in trying to understand how their system and their environment is performing within Google. So we have a very big team that works on search. We have a very big team that works on the ad system, but as I'll show you, we have several other teams that are smaller. Now, the trouble with this model is it's very easy to reinvent the wheel, and one team doesn't know what the other team's doing, and there might just be one person on a team, so they don't have any resources to draw on. So when I came to Google, I put together a kind of umbrella organization for the analysts at Google to interact. So we have a monthly newsletter that goes out with little descriptions of what kind of analysis you or your team did this month, and then we have a twice-a-year get-together where people come and listen to some outside speakers and have their own presentations and just interact so as to exchange information. I think that's been a big help because when you have a lot of people working on different slices of the company, there's always a challenge to keep their work coordinated. So we have a statistics mailing list. That's an email list inside the company. It's for people who have questions about statistics and who have answers about statistics. And there are about 650 people who are subscribed to that mailing list. And then when we have this biannual meeting I was referring to, we have a mail list of about 350 people that get invited, and then we get roughly 100 to 150 attending. So it's a fairly pretty large group of people, I would say, who are working in this area at Google. So, question I get all the time is, what does a chief economist do at Google? And my little response is, I try to answer the questions that management is going to ask next month. So I think several of you could take that same job description, I think, because it's not always just doing the analysis that's important, but figuring out what analysis needs to be done and what kind of issues are going to be arriving in the future. So in my team, I have people that work on revenue analysis, where they're doing forecasting, trying to help with planning or scenario analysis, looking at trends for different verticals, that is, different areas which advertisers advertise in, countries, products, and so on. We do what economists would call program evaluation. So we might have a new product or a new service that's become available to our users or to our advertisers or to our publishers. And then somebody needs to look at the adoption rates, the attrition rates, the impact, the performance, effectiveness. There's a lot of analysis of before and after sorts of data to try to understand how those systems work. Obviously, we do predictive modeling for advertisers. We have systems that look at new advertisers, look at their behavior, try to predict which ones are going to become successful, and try to nurture along those we think have a high probability of success. And the same thing with users. We try to determine which users, how to help users, and how to provide services that we think will be valuable to them. We run a lot of experiments. We have systems, automated systems, that are set up to run A/B experiments, treatment control experiments. Last year we ran about 5,000 experiments on the search side and about 5,000 on the ad side. So whenever you go to Google, you're probably in 15 experiments, something on that order, maybe 10, maybe 20. But of course, you could be the control in some of them, so we're doing a lot of that. Auction design, I'm going to talk about that in a second. Policy, well, we have intellectual property, we have privacy, we have antitrust, we have telecom, so there are lots of areas there where they need some economic input. You heard that I was a microeconomist. I've been drafted to do a little bit of macroeconomics because there's obviously so many events going on in the world these days that are of macroeconomic significance that people like to have somebody who can interpret the tea leaves for them, or at least explain some of the issues that we're facing as a company, as in a society. We also do a lot of work on the computational infrastructure. One of my colleagues describes himself as a computational statistician. So we're building tools that others can use at Google. We have a big group on quantitative marketing, where we're looking at various measures of ad effectiveness, one form or another. And then there's a lot of kind of random internal consulting. And I suppose if imitation is the sincerest form of flattery, Microsoft, Amazon, eBay, Yahoo, and Intel now all have chief economists. So it's gotten to be the thing to do around Silicon Valley. And what do the statisticians do elsewhere in the company? Well, we've got people who are looking at hardware. This is sort of engineering statistics, quantitative marketing, I mentioned, video and TV insights. We're doing a lot of work with YouTube, trying to understand, when an ad campaign, or not an ad campaign, but when a YouTube video goes viral, that is, experiences very rapid growth, we try to cache it. We have about 11,000 caches around the world, so we're trying to make sure that people can watch those water skiing squirrels or skateboarding dogs or whatever it is that's captivated the public imagination. We have a group doing ads quality. That's quite a large group on the content side and the search side. We have a group doing conversions and attribution. So these are all names of groups at Google. Conversion is marketing language for somebody actually buys something. So conversion is when somebody converts to being a browser to a purchaser. And attribution means you try to discover the causal factors that influence that purchase. Now, as you of all audiences will know, understanding the causality for something like that is going to be very, very tricky, but we make some attempts at least to gather metrics that will be helpful in doing that. Quantitative user experience, that basically is psychometrics, doing eye tracking studies and looking at different user interfaces and layouts, understanding consumer behavior from a kind of laboratory environment. Travel analytics, that's about our travel verticals. Sales, finance, looking at financial modeling of one sort or another. Affiliate ops, so we have lots of other websites and publishers who use Google service. People analytics, that's the HR group, the human resources group, and they have a group of statisticians there and some labor economists who study our internal behavior of our internal employees and try to understand better what will improve the situation there. Engineering statistics, I mentioned. Machine learning, which is a giant group in itself. Search quality, which is looking at ways to measure how well we're performing in the information retrieval work. We have projects like forecasting and planning, project evaluation, testing new features, modeling behavior of advertisers, publishers, and users, auction design, tool building, surveys, a pretty big set of surveys that go on with advertisers, publishers, sometimes users. And I thought what I'd do is spend the next 10 minutes or 15 minutes just giving you some examples of some of the projects. So I wanted to not go into detail, I don't think, but there might be one or two formulas, but basically I want to describe the kinds of things that we do, particularly in my group. So in many of these other groups, they are doing different things, but I wanted to talk about some things that I thought were particularly interesting. So we'll start with something that economists are interested in. How does Google make money? And the way we make money is we sell advertising. And we use a particularly interesting model for selling advertising. Of course, if you look at that picture of a Google search results page, you'll see some ads up here at the top, and you'll see some ads here at the right-hand side. And it's not hard to believe that these ads kind of get the most attention, and then these ads get a lesser amount of attention, but the attention goes down as you move down the page. Typically those top ads, people see them a lot. The right-hand side ads they see, but when you get down here, what they say below the fold, where you have to scroll down to see the ads, don't get as much attention. So some of those positions on the page are much more attractive than others, and how do you determine who gets those very prominent positions? Well, what we do is we run an auction, okay? And people ask me once a week, once a month. No, every time there is a Google query, there's an auction, okay? So we're running billions and billions of auctions a day. Now, sometimes you don't see ads on every Google page. You only see them on about a third of them. So some of the times the auction says, no, nobody qualifies. Some of the times there might be one or two ads that appear, and then other times there'll be quite a number. I think the maximum we have now is 11 ads per page. So we're running those billions of auctions, and a very simplified version of the ad auction is we order the ads by the bid per click, how much the advertiser is willing to pay if there's a click. That's not quite right, but let's take it as a simplification. The highest bid gets the best position, second highest, the second best position, and so on. Then each ad pays the bid associated with the ad below it. And people say, why do you do that? This is what's called by economists a second price auction or a second bid auction. Why do you do that? Well, Imagine yourself as an advertiser. You'd like to pay the least you can to maintain your position. So the advertisers would like to cut their bid to try to maintain the position they have and pay the least for it in a first price auction. So we just do that for them. We say, we'll cut your bid and you'll guarantee that you pay the minimum bid necessary to retain the position you have, and that makes the whole auction a lot more stable because you don't see this moving around a lot. So there's an analysis you could go through. You can find papers on this. But in the simplest case, you could think about the advertiser wanting to maximize its profit. So that would be the value of a click or the value of a visitor to your web page times the number of clicks you get minus the cost of those clicks. So there's a little formula. Maximize, wrong thing here. Maximize, here we go. Maximize value of clicks times number of clicks minus cost of clicks. And so the advertiser would want to operate at the point where value equals marginal cost. The value of an extra click would just be the value of the cost of acquiring that extra click. So the question then is, the cost function is more or less observable. The value is not necessarily observable to us, although the advertiser probably has a pretty good idea of how much a visitor is worth to their website. So what we'd like to do is estimate that marginal cost at the current operating position, because that gives us a good idea of how the advertiser values those clicks. So we have a little system called the bid simulator. And what the bid simulator does is it simulates the outcome of the auction if the advertiser changed its bid. And if you go through the details, which I'm not going to do, if you bid more, if you raise your bid, you can see where you're going to land on the page. And we have estimates of how many clicks you're going to get in these different positions. Our basic model is the total clicks is the ad-specific effect, has to do with the quality of the ad, times the position-specific effect, which has to do with the kind of user interface issues I discussed earlier. And if we're moving the same ad to different positions, we're controlling for the ad-specific effect, and so all we have to care about is the position effect. So the only real unknown is the click the advertisers would get in these other positions. And if you build this bid simulator, you can actually do a pretty good job of estimating those clicks. And in particular, then, you can estimate the marginal cost that the advertiser, or the cost function, and from that, get the marginal cost that the advertiser faces when they make their decision. So you can use that to evaluate the impact of system changes on advertisers. So you can see how the value changes. You can compare how value of advertisers changes over time. You may have a very competitive market in some areas, so the advertisers are competing intensely. In another country, it may be much less competitive. And you can compare advertiser values in different auction configurations. So you can look at what happens if there are lots of people involved in the auction or if there's just a few people. And to take a very simple example, if you have all ad slots identical, so don't worry about the position effect, and you have all advertisers have the same value, so we don't worry about the heterogeneity among advertisers, and there's some minimum reserve price. So reserve price is auction terminology. It means the minimum price you have to pay if you want to purchase the good in question, which is this case, an ad click. So if there's 3 slots and 3 bidders, it's not very competitive. Everybody ends up paying the reserve price because there's no competition there. But as soon as there's 3 slots and 4 bidders, then in the equilibrium, everybody pays their value V, their assumed common value. So you get this big discontinuity in revenue when the auction fills up. And you observe that all the time in auctions. Some of you might look at the spectrum auctions that have happened around Europe and other places where they're auctioning off spectrum for mobile phone purposes. If you have more bidders than slots, they make a lot of money. If you have fewer bidders than slots, then they make almost nothing. Good old principle of demand and supply, and it shows up in a very strong form in this auction. Now, more complex and more realistic model of the auction is we don't actually do a straight pay-per-click model. It's much more like a pay-for-impression model. So again, impression is advertiser speak for seeing the ad. So an ad impression. When you see an ad on TV or in a magazine or in a billboard or on a website, that's an impression. So we have space to put ads, just like a TV station might have space to put ads, or a magazine might have space to put ads. So we want to sell impressions, but the advertiser doesn't really care directly about impressions. They care about visitors to their website and eventually conversions or purchases. So you need a way to convert those ad impressions into those ad clicks, a kind of exchange rate. It's like I want to pay in dollars and you want to get paid in pounds. Well, we have to have an exchange rate to convert those dollars to pounds. And here the exchange rate is the click-through rate, how many clicks you can expect to get per impression. So it's quite important in running this auction to understand how many clicks an advertiser can expect, conditional on the ad impression. And it's very natural from a statistical point of view to think of that as a logistic regression. Probability of a click given the impression is a function of some explanatory variables. Now, the best variable is going to be the historical data, how many clicks per impression this ad has gotten historically. But for a lot of ads, you don't have very much historical data, and then you might think of other ads that this advertiser has put up, what the vertical is, what the country is, what the competitors of the auction is, and all sorts of other potential predictors for this click-through rate. So we run a logistic regression. It's updated in real time, and I said it's the world's largest logistic regression. I believe it's the largest because we have about 1 trillion observations for that regression. And we have, well, depending on how you count, hundreds or thousands of potential predictors. So it's a pretty big computational task. Obviously, we aren't inverting matrices. We're using some machine learning methods to do it, but it's quite a interesting system from the viewpoint of machine learning and computation. Another project that we worked on in my team is called Website Optimizer. That was a system that allowed publishers to optimize the user interface of their web page. So in the original model, you could take a proposed design and another proposed design, and then you could just alternate, randomly show one of these web pages to potential users. And after a while, you could determine whether one web page was better than another web page at maximizing some particular goal, which might be conversions or purchases on your website. Now, this turns out to be expensive, not because there's any cost to running the experiment, but because there's a cost to doing something that isn't optimal, right? You could, if you're comparing A and B, and you find out after a few hundred trials that B isn't doing so well, in the old system it just kept doing it anyway. So clearly, to make this attractive to the publisher, you'd want to use a sequential testing method. And the other thing is, doing a simple A/B testing, you couldn't really model features. So you might say that, well, I know the overall design of the web page, I just don't know which colors or fonts or images are the best. And images are quite important because maybe one shot, one picture of your product or whatever it is that you're concerned about, one picture may elicit quite different consumer behavior than another picture. So you'd like to be able to look at not just the two static web pages, but how features might drive the behavior you're interested in. So we developed a system for looking at this as a multi-arm bandit approach, which I'm sure many of you are familiar with, where you've got an objective of trying to maximize whatever your desired goal is, let's say conversions, and you've got this classic exploration trade-off. So we did this in a fairly sophisticated way using some reasonably nice theory and cost effectiveness, theory and computer implementation. it turns out this gives you a dramatic improvement in cost effectiveness for your testing, because if you're testing, let's say, 5 different designs and you find out after a few hundred iterations that 2 of them are not very good, then you get rid of those quickly. You focus in on the ones that look like they're really performing, and of course you don't care too much about the experiment if the remaining choices are very similar in performance. You've lost very little. So the big advantage is get rid of losers quickly, and you can also model features in this environment quite easily using a logit or a probit kind of formulation. Publisher quality. This is kind of an interesting story. We have a quality score for each publisher. I'm not going to go into where that comes from. It's based on observed performance. So after we've observed a publisher for a few weeks, we have a fairly good idea of what this score is. But there are lots of new publishers keep popping up. So what do we do for these people? We don't have enough information. What we came up with was really a textbook example of an empirical Bayes model. You could think about the publisher as a coin with probability P of coming up heads, where P is the measure of quality, happens to be between 0 and 1, so it's a natural model. And maybe we're looking at 2 different countries. We have a known distribution of these P's, that is, these publisher scores, within country A and country B, and we can think about those distributions as a prior over what would happen if we got a new publisher, where it's like we're reaching in the distribution, pulling out a publisher, and then we start flipping the coin. So the initial draw is drawing from this empirical distribution of known publisher scores, and then as we flip the coin, we update our posterior to reflect the empirical evidence we have on the actual behavior of that publisher. And we do just classic Bayesian updating here. My little picture of the coins is overlapped the Bayesian update statement. And this way, you get a very natural way to start out with a reasonable default and then update as new information becomes available. And of course, you can add other predictors. That would be anything that you observe at the time the publisher is created. Things like which country it is in, what the language of the web page is, what the vertical is, that is a publisher classification, and so on and so on and so on. So we do a kind of nice, I think, simple and classic textbook example of Bayesian, empirical Bayes updating. Now there are some problems because you do have a survivorship bias issue. I told you publishers are coming in all the time, but then publishers are leaving all the time as well. And so when you look at a country, the distribution of the survivors could be somewhat different than the distribution of entrants. We have some corrections for that as well. And also, you could have a potentially asymmetric loss function. It may turn out that classifying a good publisher as bad is worse than classifying a bad publisher as good, so you can make some adjustments to take account of that asymmetry. But it ends up being a pretty attractive system for solving this particular problem. A couple years ago, management said, how would the recession affect our revenue? And I said, guys, give me a break. We've only got one observation because we only had one recession. See, this is economists think that if we only had a lot more recessions, we'd know a lot more. And I think that is true, but it's not really an experiment we want to run. But then I realized we actually had 50 observations because we could look at Google revenue by state. Our systems understood the geography of where these ad clicks came from. And we could also look at economic indicators that were collected by state, like personal income or unemployment rate. So you could estimate a longitudinal model where each state had some revenue and each state had some indicator of its economic performance that reflected the recession economy, and determine the response of revenue by state to this economic metric by state. So instead of just having one time series observation, we actually had 50 observations on the states, and luckily, I guess, each state kind of went into the recession at a different time. As Michigan and the auto industry went in rather early, Texas, which was benefiting from high oil prices, went in rather late. California and New York really didn't go into a recession until the financial big drop in Lehman Brothers default and this financial uncertainty that surrounded that. So you could look at how revenue changed as each of these states went into a recessionary environment and get kind of a GDP beta. You could see how Google revenue responded to the economic indicators on a state-by-state basis, which turned out to work out quite well. And we could use that then to do some scenario planning when we were looking down the road to see what recovery would look like. Incrementality of ad clicks. This is kind of a nice one. When you do a web search, you have organic results, that is the search results, and then sometimes you have the ads. And one question would be, how many incremental clicks does that ad generate? Because if you have a very well-known brand like Amazon, then lots of people would just click on the search result and go directly to Amazon. So the ad in that case might generate relatively few incremental clicks over what you would have without the ad. So we want to investigate this incrementality of the ad clicks. That's inherently a counterfactual question, because you say, if this ad wasn't there, what would we see? And the way we did that is we exploited natural changes in ad spending. So for example, at the end of the quarter, lots of times companies will change their spending behavior either because they have leftover budget or because they've run out of budget. So you can see this more or less, or let's say it's reasonable to assume that you're seeing an exogenous variation when you have a big drop in spending or a big increase in spending, and then we try to estimate how many clicks would have occurred in the absence of that change, and we compare that counterfactual to the actual clicks. So you've got a model of how the clicks are generated, you estimate the model, look at the counterfactual, and then try to measure the incrementality of the clicks. And we set this up so it examined all the spending pattern for all the advertisers, could search for cases where we saw these large changes in the spending pattern, and then measure the incrementality according to this model. So there was a whole engineering side of this that was implementing the statistical model in a way to understand the question we were looking at. And a kind of closely related question is the incrementality of mobile queries. So everyone is familiar that mobile activity is growing. Smartphones are becoming a bigger part of the market. Lots of people are using Google on their smartphone, but from the company's point of view, you want to know, are these really incremental queries? What would have happened if they didn't have the smartphone? Maybe those queries would have occurred on their desktop or laptop computer. So you can ask about how many extra queries you're getting from those mobile devices. Obviously, it's not going to make sense to look at averages for people who have mobile devices and people don't, because there's a huge selection problem there. So what we do is what economists call a difference in differences analysis. We look at the change in behavior in those who acquire a mobile phone. So we observe somebody going along doing this many queries per week. They acquire a mobile phone. Maybe the mobile queries obviously jump. They didn't have one before. But you want to know, do total queries jump or not? Or are they just replacing queries that would have occurred anyway on the other device? So this could be modeled by looking at user-specific fixed effects, seasonal fixed effects, a 0-1 treatment, and then you write down a little model that says the queries you observe at time t depend on the user effect, the seasonal effect, plus this treatment effect. Now, of course, this is not true causality because of the selection issue, but it is arguably a measure of the impact on the treatment for those who choose to be treated. And in many cases, this is a voluntary decision. You're not going to impose a cell phone on anyone. This is the kind of thing that you want to have, impact of treatment untreated, and we can get reasonable measures of what the incrementality of the mobile queries look like. So it's quite a handy thing to be able to do. Again, there are second-order effects or refinements. People who choose a new device earlier than others are presumably different in some way, so you might look at the impact from the enthusiastic initial users as being potentially different than what would happen later on, but that can also be modeled. Give you a very quick review of something we're doing using Insights for Search. This is a little system that's available to everyone where we can show you an index of what search activity looks like on any given term. In this particular case, I typed in the term hangover, and we see it peaks every Sunday. Whoops. Peaks every Sunday, and then that is New Year's Day. Okay? Nice little outlier. And in fact, you can compare the patterns of queries. This one, I typed in hangover and vodka, and you can see queries on vodka peak every Saturday, and that's December 31st. So it's kind of a nice model of what some people call Granger causality, asking whether one time series is predictive for another. Good example to show your students. But you can use this for serious things. This is an example of something called Google Correlate, where I took initial claims for unemployment benefit, that's where people file to receive unemployment benefits, and said, what is the query that is the most highly correlated with that series? So this is just looking at simple correlation. Turns out that query is file for unemployment. And it's not too surprising, because if you became unemployed, first thing you might do is go to Google and say, how do I file for unemployment? Where's the unemployment office? How do I collect unemployment benefits? And so on and so on and so on. I'm sure it would be slightly different language here in Britain, but you get the idea. And you can see those two series are very, very highly correlated, which suggests that file for unemployment, that query activity, is a contemporaneous indicator of what the actual initial claims for unemployment look like. So we can build a model that will allow us to predict these time series, the economic index that we're interested in, unemployment or inflation or automotive sales or retail sales or any of those things, using as inputs to that predictor the Google query data. Now I'm running short on time, so I'm not going to be able to go over this particular example, but what we do is we basically combine a Kalman filter with a Bayesian variable selection mechanism and a little bit of model averaging to get our final prediction, and we have a system that allows you to almost automate this, this activity of finding predictors in the data for these kinds of economic series. So I'm quite excited by that work as an economist. All right, we'll skip that, and we'll skip back. And that, okay. Last topic. This is something we just come up with, which I think is very, very neat. It's something called Google Consumer Surveys. And the way it happens is, imagine yourself looking up something on the web, and you come to a newspaper article, and it shows you a few lines of the story, but then it says, sorry, you aren't a subscriber, I can't let you in. Well, now that publisher has a choice. He can say, you aren't a subscriber, but if you answer this little survey question, I'll let you in. And so up pops this survey that asks anything. It can ask, if the election were tomorrow, who would you vote for? It can ask, have you heard of this brand name? Or are you thinking about buying a car in the next 6 months? Whatever question you want to ask, and anybody, can use this system simply by going to Google Consumer Surveys, creating the question you want to ask, and then it's distributed out to the publishers, and this kind of survey-taking activity occurs. Now, if any of you have taken surveys on the web, you know, the response rates end up being a few percent, where here we're getting 35, 40% response rates. So it's far, far larger than you get from those kinds of surveys, and that's because the user is actually getting rewarded. They're able to get to the content they want to get to. So this is a little example what the output page looks like, where you can see this question is, would you say that you and your family are better off or worse off financially than you were a year ago? And this is looking at the responses these individuals made. Over here, you can break them down by inferred demographics. This is our estimate of demographics based on web browsing behavior and some of the cookie information and some of the census information in the US. So we have a way to estimate not only the response, but also what the demographics of the survey recipient is. Okay, last two slides. Experimentation. I alluded to this earlier. We have pretty elaborate systems to do all sorts of experimentation on the web page, search results, and on the ads. We could do query experiments where you're treating different queries differently, cookie experiments where you're treating different individuals differently on a persistent basis, geographic experiments where you're targeting certain regions or metros, and of course temporal experiments where you turn something on for a while and turn it off. So there are lots of different ways to do this kind of experimentation, and it's absolutely critical, obviously, to understand anything that's really a causal relationship. Lots of other stuff. What are we looking for in new hires? We want people who have a broad knowledge of statistics, and I think it's a little different than academia. As an academic, I can say that there's a lot of rewards to specialization, but many times in industry and at Google, we're looking for people who have a broad education and are familiar with many different areas, as well as having some depth. We want computer coding skills like Python, data and database manipulation skills, SQL and so on, machine learning, visualization, and very importantly, communication skills, because you have to explain what you're doing to people who are going to implement or use the discoveries that you've made. Understand the question, understand the domain, ask the right questions, use the right tools, and do it fairly quickly, because when you're working in a very competitive industry, you have to think about getting your job done in a matter of weeks, not really a matter of months. I'm going to skip that and end with this slide. It's not just Google. Everybody is collecting huge amounts of information. If you look at Intuit, Visa, MasterCard, Walmart, Safeway, all of these guys have data warehouses. All of them are getting very valuable information from this measurement that they're now able to do, and the real gap is in finding people who can make that information tell its story. So I'm going to now insert my little ad. Google's hiring statisticians in the UK. I don't think this will be viewed as particularly annoying. And this is one page on statistician engineering analyst, and here's another one on quantitative marketing manager in London. So we're definitely looking for people who are interested in working on this set of issues. So thank you for your attention.